Yeah, so in limits and in, so it's basically calculus, whatever I've.
Oh, okay.
So yeah. So should I send you the pictures or like of the sums, or do you want me to just tell you what we thought?
Why don't you tell me? I'll try to put it on the document camera and show you what I've understood. And if you find something is wrong, you can tell me. Right? So,
Yeah.
is the document camera on?
No, it is on like this. Just a minute. Need to go through that. Camera, I don't need to open it.
Where? All right. Have to share screen, right?
Yes, yes. Shruti, is visible? This.
Are you able to see?
Fine.
Yeah.
Okay.
I need to see this.
It has light.
No, not servicing.
It should switch on.
So it's automatically switch on, no?
No, automatically it doesn't. There are three. It's not switching on. Just wait. No, it's switched on. Okay. Tell me. Go ahead.
So f of n
F of n.
equals
F of n.
1 by n.
Now tell me if you're able to see this.
I'm not able to see anything you've written. I can see
Yeah, but are you able to see a blank paper now?
Yeah.
Okay, we start. F of n equals
1 by n
okay
into open bracket
times
the curly bracket.
open bracket. Okay.
2n plus 1
2n plus 1
into 2n plus 2.
into 2n plus 2.
So it goes on like that till 2n plus n.
2n plus n.
So and that to the power 1 by n.
Whole to the power 1 by n.
Yeah. So what is the limit of this function as n tends to infinity?
Okay. Limit as n goes to infinity of f of n equals what?
Yeah.
All right.
Yeah.
Good. So what was your approach to doing this?
So what I did was I took n inside, so I made it the 1 by n, took it as n power n, and put 1n under each term. Under 2n plus 1, 1n, another n below 2n plus 2.
So you have 2n plus 1 divided by
n
n.
into 2n plus 2 divided by n.
Okay.
So you go all the way till 2n plus n divided by n, and the whole thing is to the power 1 by n. So you can take n.
Whole to the 1 by n. Very good.
Yeah.
So because
And
you get n to the power of n whole to the 1 by n,
yeah.
which gives you n,
Yeah.
and then n comes
Yeah.
up, right? All
Yeah.
right. Now what?
Then, so I did log of a into log b is, so I took log on both sides basically.
Okay, so now let us set this up as y equals this particular thing. Then you're going to do log y equals 1 by n log of 2n plus 1 by n, 2n plus 2 by n, so on up to 2n plus n by n. Okay.
And so now, because log of a into log b is log a plus b.
Okay.
So I split it up into individual
1 by n times log 2n plus 1 by n plus log 2n plus 2 by n plus
2n plus
log 2n plus n by n
And then I split it up into difference. So 2n plus 1 by n minus n.
All right, very good. Like your approach so far. So log 2n plus n minus log n plus log 2n plus 2 minus log n.
Yeah.
So on, then you get log 2n plus n minus log n. All right.
Yeah. Yeah. And now if you what happens is you can see that ln n is coming n times. It's appearing n times.
Yeah, n log n. So 1 by n log 2n plus 1 plus log 2n plus 2 plus so on log 2n plus n minus n log n.
N log n.
Okay.
Yeah, and then you take 1 by n inside. The 1 by n into n goes.
Okay, I take 1 by n inside. Then
1 by n log.
So log n 2n plus 1 by n plus log 2n plus 2 by n plus so on log 2n plus n by n minus log n.
Yeah, and
Okay.
then to apply L'Hopital's rule for this part.
Okay.
For each, except for ln n, you apply it for everything, and you get a harmonic progression.
Okay, so you're going to say limit as n goes to infinity of log y equals limit as n goes to infinity of log 2n plus 1 by n plus so on up to log 2n plus n by n minus log n. Yeah?
Yeah.
Do I have this right?
Yeah.
Okay, and then what?
And then you apply L'Hopital's rule for all the terms except that minus log n.
Okay, can we do that?
You do
Okay.
it for the individual terms in
So I can, so I'm getting, so if you did that, each of these terms log n, log something by n, that is going to go to, what will that go to? Log 2n plus 1 by n as n goes to infinity.
1 by 2n plus 1 into 2 plus 1 by 2n plus 2 to 2.
2n, no, I don't get it.
Because it's infinity by infinity, right? So it's in that form.
Yes. Oh, you don't have to do all of that, right? Okay, by now, you know that log goes to infinity lot slower than any polynomial. You agree?
Sorry.
If you look at functions, log x goes to infinity. As x goes to infinity, log x also goes to infinity, right? As x goes to infinity, a polynomial of the form, let's say a x to the n, a n x to the n, plus a n minus 1 x to the n minus 1, so on plus a naught. I'll write it here. See, log x goes to infinity as x goes to infinity.
Yeah.
Right?
Yeah.
If I take any polynomial, 3x squared, let's say, plus 5x plus 6, this also goes to infinity as x goes to infinity.
Yeah.
But what do I know about this function and what do I know about this function? Log goes to infinity slower.
Yeah. Because it's just okay. Yeah.
Than any polynomial. So for example, if I take x and I want to compare it with log x, when x is 10, let us say this is log base 10, okay, for example. When x is 10, what is log x? 1. When x is 100, this is 2.
2. Yeah, so it's much slower.
Yeah, when it is 10 to the 6th, it is just 6. So as I'm raising towards infinity, this thing is going towards infinity much slower.
Yeah.
So whenever I have log of something divided by a
That's
polynomial,
the way that the log curve is.
yeah,
You
what?
never touch it.
Yeah. So the polynomial will raise to infinity much faster. Log will go to infinity much slower. So the ratio will go to 0.
Okay.
Is that fine?
Yeah.
So you don't mean you can do L'Hopital. You can take L'Hopital's rule and you can show that. But as a rule of thumb, you don't have to worry whenever you have log of a function divided by a polynomial, the log will inch to infinity much slower than the polynomial. So the polynomial will raise to infinity, which means if I take the ratio of a log and a polynomial, the ratio will go to 0. Okay? So it can be shown formally by L'Hopital's rule, log x by x, limit as x goes to infinity is in the form infinity by infinity. So I can do L'Hopital's rule. By L'Hopital, I can do, what is the derivative of log x? 1 by x. And derivative of x is 1. In the limit as x goes to infinity, 1 by x goes to 0.
Yeah, okay.
Right? Anytime you see a log in the numerator and you see a polynomial in the denominator, you know that it goes to 0.
Okay, yeah.
So here in your problem, each one of these things that you have, are you able to see it? This one goes to 0.
0. Okay.
So what about this
But
one?
0.
Yeah.
Right?
Well, yeah, each of these go to 0, right? So you're left with this. You're left with this. And this thing goes to?
I don't know.
As n goes to infinity, what about log n?
Infinity.
Infinity. So this whole thing goes to minus infinity.
But the problem is I thought I did so I used L'Hopital's rule and I took it like a lot of steps further. But the options are 4 by E, 27 by 4E, 27E by 4, and 4E.
Yeah, we are okay. So what are your options?
4 by E.
4 by E. Second one. Hello, Shruti. Hello? Shruti? Hey, what happened? Dinu, I need some paper. Yeah, Shruti. Hello? On start video. Okay. Shruti, are you able to see me?
I can't see you. I can hear you.
You are able to hear me?
Yeah, I can't see.
Will it disconnect? Yeah, there's some issues has come. Suddenly disconnected. You need to restart. Then I have to restart that.
Because you.
No, this happened yesterday. Now it's audible, Shruti?
I can't see.
Yeah.
I can't even see.
Are you able to see?
Yeah, now I can.
It's coming?
I can't see you yet.
Just wait. The camera is, I think I need to reconnect this.
Start video.
Yeah.
Start video.
Yeah.
Are you able to see me?
Yeah.
Ah, good.
Now it can come.
Okay, now you go ahead. You tell me 4 by E.
But I can't see what you're writing.
Yeah.
Yeah.
I'll just show it to you in a moment. Are you able to see it?
No. 1 second. Yeah, but yeah, the options are
Yeah.
4
by E.
27 by 4E.
27 by 4E.
27E by 4.
27E by 4.
And 4E.
4E.
Yeah.
Right. So I went with what you had done. Let's now begin to look at how things are going here. So I have f of n equals 1 by n, 2n plus 1, 2n plus 2, whole to the 2n plus n to the 1 by n. Okay? And you want limit as n goes to infinity, f of n equals what? Right? So here is what I'm okay with you taking this in. So f of n equals 2n plus 1 by n, 2n plus 2 by n, plus, dot dot dot, so on, 2n plus n by n whole to the 1 by n.
Yeah.
Fine so far? Okay, I'm now going to pull an n out of every one of these terms. This is equal to, n comes out, 2 plus 1 by n by n cancels. You see this?
Yeah.
Then I pull an n out, then 2 plus 2 by n by n. Those two cancel off. And then I have n comes out of here, 2 plus n comes out. I pull an n out. I pull an n out here. 2 plus 1 by n, right? N and n whole to the 1 by n. Are you okay so far?
Yeah.
All the n's have gone.
So just 2 per n per 1 by n.
Now, here's the question. 1 plus 1 by n whole to the 1 by n in the limit as n goes to infinity equals what?
It's 1, right? It's 1, right?
Is it 1? What do you want? Huh?
1 by infinity.
Just
1 plus 1.
1 minute. Just 1 minute. Here is something he wants to do. Okay. All right. So we want to see what is 1 plus 1 by n whole to the 1 by n as n goes to infinity.
Yeah.
Okay. My claim. Okay. So let us see. So y equals 1 plus 1 by n whole to the 1 by n. Let's make it a plus 1 by n. Okay.
Okay.
So a plus 1 by n.
Yeah.
Now I'm going to take log y equals 1 by n log a plus 1 by n. Fine?
Yeah.
Now limit as n goes to infinity of log y is equal to limit as n goes to infinity of log a plus 1 by n divided by
1.
divided by n.
Yeah.
Now I'm going to let n go to infinity, right? And I know that a is greater than 1.
Yeah.
Then what happens? What happens to the limit? As n goes to infinity, this will go to?
Oh, 0.
goes to 0.
Yeah.
Which means if log of this goes to 0,
it's 1.
This is equal to 1.
Yeah.
This
Yeah.
a plus 1 by n
Yeah.
whole to the n. All right. So now a plus 1 by n. Can we now look at b plus? So now we have 2 plus 1 by n whole to the 1 by n times 2 plus 2 by n whole to the 1 by n, so on. And then finally I'll have 3 whole to the 1 by n. Is that right? Am I good so far? All I have done is distributed the 1 by n to each one of these things.
Yeah.
And then this is f of n. Fine. And now I want to do limit as n goes to infinity, f of n equals limit as n goes to infinity, 2 plus 1 by n whole to the 1 by n.
Yeah.
2 plus 2 by n whole to the 1 by, limit n goes to infinity of this, limit as n goes to infinity, 3 whole to the 1 by n.
Yeah.
So what happens now? What happens to this thing? As n keeps going towards infinity, what will happen to 3 to the 1 by n?
It goes to 1.
Yeah, this goes to 1. What about this?
1.
1. What about this? 1. So each of these go to 1.
Yeah.
So in this entire thing goes to 1.
Yeah. That's the limit.
This is what the limit is. So let's check if we have made any mistakes, and then see why the 4 options given: 4 by e, 27 by 4e. Do you have the problem with you?
Yeah, I do.
Can you show it to me on the camera? Maybe did we miss any plus, minus, anything anywhere? Can you just show me the problem before?
Yeah. Yeah. Can you see it? Number 2.
Which one? Number
2.
2. No, I can't. Can you take a?
Should I send you a picture through email?
Yeah, exactly. That's what. Can you just zoom in and take a picture of that? Yeah. And will you be able to send it? You can attach it here itself in this chat. You can send on the chat itself.
But I'm sending it through phone. So this is the computer. So I'll send it.
Where will you send it? To which email?
To global line, whatever I've got.
Oh, okay, send it there. Can you log into that?
Yeah.
In the meantime, I'll take a look at the problem they have given. Everything is fine. Yeah.
Okay.
Good. That's it. Nice sequence.
Yeah, I've sent it.
Okay.
I've actually been trying this sum for quite a while. I'm just getting different
I'll try to take a look. We'll look at any mistakes that we might have made. First, let me look at the problem itself, and then figure it out. Just
no, they received it.
It came.
Yeah, yes.
Yeah, number 2.
Ah, yes.
Save it, or you can see that.
I can see that. Just a minute.
Yes.
Leave it. Can I zoom this?
No, I have to download it.
Yeah. Save picture. Save picture. That's okay. I'll do it. Right, I'll save it on the desktop.
Next to yes. I put it up.
I'm just taking a look at the problem. Okay, are you able to see me?
Yeah, I'm
Oh, okay.
and the
F of n equals 1 by n to n plus 1. So all of it to the 1 by n. All right. And then limit as n goes to infinity. F of n equals 4 by e, 27 by 4e, 27e by 4, 4e. All right, let's see. So what did we do here? Let's run through our solution. We brought 1 by n is outside this. So n to the n whole to the 1 by n. So you're distributing n of these things. So 2n plus 1 by n. So 2 plus 1 by n whole to the 1 by n, right? That is what we have. Individually, we have 2n plus 1 by n, 2n plus 2 by n, 2n plus n by n whole to the 1 by n. And then that became 2 plus 1 by n, 2 plus 2 by n, and then so on up to 3. We can now try just to see, just to do a sanity check. So you have, are you able to see? Sorry.
Can you put the camera on the paper?
Now are we okay? So we are at this point where we have brought the n in, and then you have this, right? Are you able to see that? Okay, good. So now let's do 2 plus 1 by n whole to the 1 by n.
Yeah.
2 plus 2 by n whole to the 1 by n. So on, 2 plus 1 whole to the 1 by n. This is equal to f of n, right?
Yeah.
Now let's do the log trick. So log f of n equals log 2 plus 1 by n whole to the 1 by n plus 1 by n 2 plus 2 by n plus so on 1 by n log 3, and that's it, right? Now in the limit as n goes to infinity, we want to find what is log 2 plus 1 by n divided by n. And that is equal to? What is this?
1.
It's equal to 0. Right? Because log of something will go to infinity slower than n.
Yeah. It's 0. Sorry. Yeah.
So I get 0 for this, I get 0 for this, I get 0 for this.
Yeah.
All of those are 0. Log of something is 0, which means f of
That
n
has to be
must be e to the 0, which is equal to 1.
1.
So I really don't see how.
Yeah, I think it's wrong.
Did you get 1?
I didn't. No, I don't know. Wait, I just checked.
But are you convinced
No, I
with
think
this
it was
method?
after a certain number. I never went ahead.
Okay, but are you convinced with whatever we have done so far?
Yeah, I am.
I'm pretty convinced with whatever we have done. I don't see any obvious mistakes in what we have done.
Yeah.
And I see that it converges to 1.
Yeah.
Okay, a quick.
Yeah.
Shall we do a quick check?
Okay. Yeah.
Do you have a problem like this? Let us say you're trying to do by yourself, and then the solution comes out to be something else. You want to see if you are right or the solution is right. Now, what do?
Put in the answer and go back.
Let's try n equals 10 power 6.
Wait, so the answer for this one is option.
No, Shruti. Don't go into the answer there. Just let's plug it into one of the online tools. We'll evaluate this function at n equals 10 to the power of 6.
Okay,
Okay, and we'll evaluate what this function is.
Okay.
That should give us an indication if we are right in what we are doing.
Yeah.
Fine.
Yeah.
I'm going to tell you this website. Let's go to Wolfram. You know Wolfram? Wolfram Alpha?
No.
WOLFRAM.
I can see it, yeah.
Alpha. You're able to get it? Okay. So now I'm going to go in. Yeah, I'm just getting into the computational engine there. I'm going to put in 1 by 10 to the 6 times 2 plus 2 times 10 to the 6 plus 1 times 2 times 10 to the 6 plus 2 times 2 times 10 to the 6 plus 3, and then can I do sigma? Can I do alpha? Just 1 minute. Pi I can do, right? Just give me a minute. I'm going to put it into the machine, into the computational engine. I'm going to evaluate it and tell you, right?
Yeah.
Just 1 minute. Product. Let's say 2n plus n. Okay, so now here is another interesting thing you should, in trying to do this problem, another quick check to see where this problem lies. Okay.
Yeah.
You have 2n plus 1, 2n plus 2, so on up to 2n plus n, right?
Yeah.
Now, assume that all of these are 2n plus 1.
Okay,
Then how many of these you have?
N of them.
N of them. So it is 1 by n, 2n plus 1 whole to the n whole to the 1 by n.
Yeah.
And that is equal to how much?
Can I see the? I think it's.
Yeah, I'll show you. Are you able to see this now?
Yeah.
See, I have 1 by n. Instead of 2n plus 2, 2n plus 3, 2n plus 4, I have 2n plus 1 whole to the n. Whole to the
This
1
is 2n
by
plus 1 by n. Yeah.
And this is equal to 2n plus 1 by n.
Yeah.
And then if
Which is
n
2
and n,
plus 1.
2 plus
1 by n.
1 by n. So this tells me in the limit as n goes to infinity, this whole thing 2n plus 1 whole to the n 1 by n is equal to 2. That is the lower limit.
Yeah.
What about the upper limit?
2n plus n.
Yeah. So let's go for 2n plus n whole to the n whole to the 1 by n
by
1
n.
by n. And this is equal to 1 by n and n and n will cancel off. N will come out of here. N times 2 plus 1 by n, and that is equal to 3. So this tells me that my number, that this limit n goes to infinity of f of n is less than or equal to 3.
Yeah.
And is greater than or equal to 2.
Yeah.
So my 4 options, if I look at it, 4e cannot be between 2 and 3.
No, it can't be.
Gone. 4 by e.
4 by e.
E is about 2.7.
Yeah.
It cannot be.
No, but 4 by e can be, right?
It's 2.7.
Oh, yeah, it's 1 point. Yeah.
Yes. All right.
27 by.
27 by 4 times, let's say 12. So that is about between 2 and 3.
That's the answer.
Yeah. And then 24e by 4 is way more than 3.
Yeah.
So I've already got the answer to be 27 by 4e. And I see you smiling.
So why is what did it go? What went wrong there?
Yeah, we'll get to it. Just wait. So now we have to go back, right? This is how you do it in the exam.
Yeah,
Right?
that's the simplest.
The simplest thing is find a lower bound, find an upper bound, see which of these are between the lower bound and upper bound. In fact, even without evaluating what it is exactly, I could find out that the answer was 27 by 4e. Good.
Yeah.
So now let's go back and probe and see how we get 27 by 4e. Fine?
Yeah.
All right, let's do that. So that means there's something fishy about what we did, and we got to fix that. You feel like beating yourself up?
Yeah.
This is beautifully, it came out, right? So now let's see how to get it. So these tricks, I didn't know this problem, right? Before you asked me, I've not seen the problem. Hopefully you will go to the point where you can generate such ideas by yourself. So let's look at it. So 2n plus 2, so on, 2n plus n whole to the 1 by n.
Yeah.
So let's stare at it for some time. Let us see how to take a stab at the problem. So am I making any mistake if I did this is equal to 2n plus 1 by n 2n plus 2 by n, 2n plus n by n whole to the 1 by n.
Yeah.
So far, that'll give me n to the n whole to the 1 by n and n to the n by n. That'll give me n out. I think so far I have not violated anything.
Yeah.
You agree?
Yeah. But maybe the point where you went on the previous one is the limit. Is limit of AB limit of A into limit of, can you do that?
Yes, provided limit of AB or AN BN equals limit of AN times limit of BN, provided limit of AN exists and limit of BN exists.
Okay. Okay.
As long as that is true, then I can do the split.
Okay.
Okay. So now let's now go for it. Let's so far so good. I don't see any issues so far. Okay, so now if I do the next step, which is pull an n out, I'll get 2 plus 1 by n. By n and n cancel off. 2 plus 2 by n. 2 plus n by n. 2 plus n comes out, n times 2 plus 1, right? So 2 plus 1, n by n is just 1. All of this raised to the 1 by n.
Yeah.
So far, I don't think I violated anything. I think I'm fine.
Yeah.
Now this is equal to 2 plus 1 by n whole to the 1 by n. 2 plus 2 by n whole to the 1 by n. 3 whole to the 1 by n. Let's check. AB whole to the n equals a to the n, b to the n. So,
Yeah.
so I really haven't, I think I'm fine with this as well.
Yeah.
Am I not?
Yeah.
We're fine with that. All right. Then where are we? Then where were we headed with this? 2 plus 1 by n whole to the 1 by n. 2 plus 1 by n whole to the 1 by n in the limit as n goes to infinity.
Yeah.
Now let us see. What is this equal to?
I also write.
2. So let's do an evaluation. I want to check if to limit. So I want to see if limit. So are you on Wolfram Alpha?
Yeah. Wait.
So,
Yeah.
so we want to see how to compute this limit. Okay. So what we'll do is lim, or okay, as x goes to lim.
Yeah.
Lim 2 plus 1 by n whole to the 1 by n.
Yeah.
As n goes to infinity, right? As n tends to infinity. As n tends to infinity, INF infinity.
Yeah.
Are you able to do that in your on your screen?
Yeah, I can see it. Yeah.
So you're getting 2 plus 1 by n whole to the 1 by n is equal to 1.
1. Oh.
So that's interesting. So we get 2 plus 1 by n whole to the 1 by n is equal to 1.
Yeah.
And each one of these, I bet you, is going to be equal to 1, which
Yeah.
which is
Bring back to the same.
which is going to give us 3 to the 1 by n will also be equal to 1, right?
Yeah.
Because where are we? Yeah. So now let's see where we could have, where are we going off on this one? So if instead of this I had enough of these guys, each of these being 2 plus 1 by n,
Just put it on the paper. You should switch the camera to the.
Yeah. You're not able to see the. Are you able to see it now?
Yeah.
Okay. So if I, instead of doing this, if I did 2 plus 1 by n, 2 plus 1 by n, 2 plus 1 by n,
Yeah.
whole to the 1 by n.
Should still been 1, right?
Let us see. It won't be 1.
Oh yeah, it'll be 2. It'll be 2.
Yeah. So.
Yeah.
So where are we? Where are we going off? Where are we going?
Yeah.
Off? That's the question, right? So in this case also, if I bring in 1 by n, then I'll get 2 plus 1 by n whole to the 1 by n times 2 plus 1 by n whole to the 1 by n, so on 2 plus 1 by n whole to the 1 by n.
Yeah.
If I do that, I get only 1.
Yeah.
In the limit, as n goes to
That's so
infinity.
good. Good.
But if I didn't do this, if I
You
did
would have
this
gotten 2. Yeah,
whole to
that's
the
that's.
n by n, then I'm going to get 2.
So you basically can't do this. But why?
But why? Yeah, that is the thing that we have to now figure out. So let's stare at it for a few minutes. Try to see why we can't do that. 1 by n comes in as I distribute. I know why.
Why?
Because when you do this 1 by n, if you distribute it inside, you are assuming that these are finite numbers. You understand what I'm saying?
No.
Okay, how many of these terms do I have?
Wait, can you use the camera?
Yeah, here. You're able to see it?
Huh.
How
Yeah.
many of these guys I have? I have n of these guys.
Yeah.
But my n is tending to
Infinity.
If I had exactly 10 of these guys, see,
Yeah.
AN, BN, CN, A1. Okay, suppose I had A1, A2, A3 up to A10 whole to the 1 by n.
Yeah.
That is equal to A1 to the 1 by n, A2 to the 1 by n, A10 to the 1 by n.
Yeah.
But if I had A1, A2, so on up to AN whole to the 1 by n, and n goes to infinity, I had infinite number of these guys.
Yeah.
Then I can't distribute 1 by n.
Yeah. Yeah.
Right, that's where the catch is. So you can't do that. You can do it only if
Yeah.
the finite number of products. You have infinite number of products as n goes to infinity. Good? Good.
Yeah, I got it.
You learnt a lot. Just
Just 1 minute.
one problem, you learnt
Yeah.
quite a bit.
Yeah.
All right. Still, we got the lower limit, we got the upper limit. That gave us what the answer was. But let's try to see if we can now try to do this analytically and try to get it. Okay? But then, if you try to do that,
We anyways got the answer. Can we just leave it?
Okay.
It's just
So
too much.
you're okay with one solution? The lower limit, the upper limit, kind of giving you
And finding
pointer into how to do it. I'll also tell you how to do it fully analytically. Okay? Because if you do this, now what happens is you get an infinite series.
Yeah.
No. What's her name? Shruti.
Yeah.
Did you understand what I said just now? It's a very, very deep statement.
I got it. It's like not sunk in, but I got the idea.
The idea is if you take log, you don't get a log finite number of sums. You get an infinite sum. So that is an infinite sum. And that
you can't
series will converge.
What will converge?
That infinite series will converge.
Yeah.
And that convergent, it will converge to that number that they have given you there.
Yeah.
27 by 4e. That is the convergence.
Yeah.
Got it? You get the idea at least. You get a log of sums. Those sums are not finite sums. It's an infinite sum. That infinite series will converge.
Okay,
That infinite series converges to 27 by 4e.
Yeah.
Okay? I'll leave this problem at this point. If you want, attempt it. Next time I'll give you the full solution. But here is the thing, Shruti. So here is the philosophy of the class, right? We will always, I will allow you to stab the problem first. And I'll try to see on which path you go. Okay. Because that allows you to, your intuition to build up. And then if there is a mistake in the path that you have gone, I'll try to point that out so that you realize that particular mistake. And I'll try to guide you towards the right way of doing it.
Yeah.
And then again you will do it. Right? So the point is for you to do it, for you to feel it, that way you own the problem. Right? When you do it, that is when you fully get it. When I do it and you see it, it is like watching, do you watch cricket or tennis?
Yeah, I watch both,
You watch both. So if you watch Federer play tennis, doesn't mean you can play tennis like Federer, right?
Yeah.
You have to get your hands dirty. Or if you want Kohli hit the shots, doesn't mean you can hit the same shot. You have to get and do that, right? So all I'm going to do is make you do it. So somewhere I want you to have these papers, paper and pen handy all the time.
Yeah, I do,
You will tell me how you're going through it, and then I'll try to fix any mistakes in your approach. Or if there is an obvious approach that I feel is better, I will guide you through it. Is that fine? That will build up your intuition.
Yeah.
So what is the key point that you have learned from this problem?
It's lots of things actually. But
it is an infinite product. And so the distribution of 1 by n over an infinite product, I don't know if I can distribute it. If it was a product, I can distribute it.
You could have done it, yeah.
And then, because it's an infinite product, if I take log, it becomes an infinite sum.
Yeah, and you have to find that sum.
Yeah, that infinite series will converge, and that converges to 27 by 4e. Fine, we'll take a stab at it tomorrow again, but at least you understand the basic idea that the flaw of distributing 1 by n to all the terms and then saying that each of the terms goes to 1, there are infinite number of 1, so it is 1, that is wrong. So anytime you distribute, you have to see if there are finite number of terms, and if there is a limit which says that n goes to infinity, then your number of terms is not finite, it becomes infinite. Okay. Good. All right, for the next one, shall I take a stab at the next one?
Yeah, I didn't even try it. I knew I wouldn't get it. I left it.
Which one? Which one?
Third one on that picture.
Yeah, I see one more up.
Yeah, that was so. No, wait. Okay, wait. There are lots of doubts. Can we do this one? Because I attempted to do this.
Which one?
I'll send you the picture.
Hey, but Shruti, wait a second. How do you want this class to run? You want it to be like randomly you'll take problems and you will give it? Or should we take a topic, discuss problems in that particular topic, and then keep going topic by topic? How do you want to do it?
Can we do it as a mix of all chapters? Like questions and doubts? Or what do you think is better?
No, where is your preparation level? Okay, so now what is this book? First of all, which book is this one?
I ordered this online for KVPY because that's what I want to write in November.
Is that your target?
Yeah, that's my target.
So the objective of this class is to enable you to crack KVPY?
Yeah, but I also want to understand, like for example, the infinite terms thing. I want to learn. So, but with this exam, with these kinds of questions.
All right. So it helps me focus myself and help you better. That's all. That's the only reason I'm asking all this. So you want to get into KVPY, and we'll have KVPY as our objective, but using that as our broad canvas, we'll also try to make sure your conceptual understanding is on solid grounds. That way you know that you are able to attempt all the problems properly. Is that the summary of what you want to do?
Yeah.
Okay. And how far are you on this KVPY preparation?
Actually, what I've been doing is over this summer, I've been trying to focus on only math because physics is a bit, I'm not very comfortable with physics as I am with math. So I've been doing math, and I've been trying to do as many sums as I can from in math. So I've done parts of straight lines, trigonometry. I did quadratic equations and all those chapters. So I've been trying to finish it, but even there, I'm not getting sums, and I'm getting stuck. And it's the same level of sums I'm getting stuck at. I'm not able to, because there's no one who's able to answer the doubts I have.
Okay.
So yeah.
So was today's thing useful for you?
Yeah, it actually was, because I've actually tried out Alan. I quit after one class because I didn't think they were teaching well enough.
Okay.
So yeah, this is better. Like yeah.
So we'll stick to this style of doing things then.
Yeah.
But it'll be better rather than me come and then you throw a problem at me and take a stab at it on the fly. If I prepare for these problem sets before and come, it will be a better use of your time.
Yeah.
Right? So otherwise, my time will be gone in just doing one or two problems. If you tell me for next week or for the next class, this is the set of problems I want you to take a look at. I can take a look at those problems and come back to you. I'm not going to tell you how to do the answers. I want to see how you have attempted it, and I want to fix any mistakes in the way you have done it. And then if there is any obvious flaw in the way you're doing it, then I'll guide you through the way you should look at it.
Yeah, that would be good. Yeah, that'd be awesome.
We'll do it that way. So now give me a set of problems for next time. What you do is you will take a photocopy of it, or you will send me a picture of those set of problems, mail it to the global IAE this thing, and then I'll take, I would think if we are going to have 1.5 hours, I would think top 6 to 8 problems you can send every time.
Okay. Yeah.
That is being very aggressive. 8 problems if you can do, that is being very aggressive. Maybe, but anyway, it's better to be over prepared than to be under prepared. So send me 8 problems that have bothered you.
Yeah.
And we'll systematically work through this.
Yeah.
Okay.
And if you want me to do, I can do stuff at home and come and like outside the class and come with all the doubts.
Yeah, you will attempt it, and then whichever things stump you, you will send me. See, for today you already have another set of 8 that have stumped you. You send it.
I have more than that actually. Yeah.
So your bank of problems are already there, and all you're going to do is keep pushing it off to me. I will work it out. I will have it ready, and then I'll start listening to you about how you went about solving it, and we'll have a discussion around it and see what needs to be reinforced in your understanding so that you get it right.
Yeah. Okay.
Sound good?
Yeah.
Okay, so I'll expect your email. Shall we? Do you want to do one more problem, or shall we call it quits at this point?
We'll do one more.
One more. All right, let's go for it.
Yeah.
Okay.
I'll just send a picture to the group live.
Okay. Huh? Yeah. Hey, Shruti, can we meet from 6:30 to 8 on a regular basis? Would that work for you?
Yeah. That's perfect. Yeah.
Okay.
I'll just...
You can, Shruti, you can call me Chandra.
Okay.
Okay. Good. I'm glad you gave a nice problem. It was fun solving it.
There have been so many of them that have been like irritating me throughout the summer, and like there was one which took 3 weeks. Finally today morning I got it, and I was just like, yes.
Very good.
Yeah, I sent it.
You have sent it? Okay. Yeah. She has sent this one. Number 7.
Yeah.
All right. That looks like a nasty one. All right. So limit as x goes to infinity, 2 to the x to the n, whole to the 1 by e to the x, minus 3x to the n, whole to the 1 by e to the x, divided by x to the n, where n is a natural number, is a log n times 2 by 3 b 0 c n log n to the 2 by 3 d. Can you also just on the messaging window, can you message to me the name of this book?
Yeah.
So that maybe I can even purchase this book. She has sent it to you?
Not yet.
All right. So here is what I have. Is this right? Okay. What is your take on this problem?
Clueless. I tried.
Come on, tell me something. I'm seeing I'm seeing 0 in it.
Yeah, 0 by 0. So no, 0 by infinity.
Yeah. I mean, on a rough cut, I directly see a 0. Are you able to see the 0? Let's do this. Shruti.
Yeah.
Forget all of this. Just take a look at this. I am raising 2 to the x to the n. X is going to infinity, right?
Yeah.
So this thing is going to some big number, right?
Yeah.
And then I'm raising this whole thing 1 by e to the x.
Yeah.
As x goes to infinity, e to the x goes to infinity. 1 by infinity is going towards 0.
0. So it's 1. Yeah.
Having some number raised to the 0, which is 1. I'm having another number here. Doesn't matter what this is. Some huge number. But then when I do this, it is going to be 1. 1 minus 1.
It's, it's 0. It's 0. By x power infinity, 1. Yeah, it's 0.
So that would be my first guess.
Yeah. That's
right?
the answer.
Yeah. So you just see it and the answer jumps out. Right?
Yeah.
Now you are convinced? Yeah, good. So
Yeah.
all right. Shruti is saying one more. You want to toss one more?
No.
Shruti.
No. I'm done.
You're done? Okay, good.
Yeah.
So we'll continue this. I'm very happy that you're grappling with these problems. I'm happy to be part of your journey. It'll be a pleasure to help you reach your goal. So send me the title of this book and send me.
Yeah, I've
send me some 8 problems every time we finish a class. Send me 8 problems. We'll discuss those problems next class.
So we'll continue with limits tomorrow also, or whenever the next class is.
Sure. Do you want to do that tomorrow?
Yeah.
Yeah. 6:30 tomorrow.
Yeah.
Good. So do you want? Okay. Wait. Shruti, in there. See, I'm traveling from one place to the other. So if at all I'll try to be on time by 6:30.
Yeah.
30 plus or minus 10 minutes. Okay.
Yeah.
Between 6:30 to 6:45.
Yeah.
Cool.
That's fine.
But we'll log in at 6:30.
No. So there's a permanent. You don't have a permanent one?
Yeah, it's permanent.
No.
Right?
All right, Shruti. See you. Catch you tomorrow.
Okay. Bye.
Bye bye.
Yeah.